So you can see that the calculations using sine and cosine to find an angle are exactly the same steps as using tangent, what we've done before. That's the same whether you're trying to find a missing side or a missing angle. The only difference being is that you need to make sure that you use the right trig function, sine, cosine, or tangent. It's all based on the question you're given. So as you're working through those calculations, make sure you have that idea or have that written down somewhere. For me, it's always formula, substitute, calculate. It gives me a nice logical progression on how to work through questions. It allows me very little space for mistake. Yeah, it takes a little bit longer to do the work and to show the work, but as you work through them, it does get easier and it does get faster. So example 3 here, the only thing that we can add on or make things a little bit trickier now is put all this information into a word problem. So here's our word problem. An observer is sitting on the dock watching a float plane at the Vancouver harbor. At a certain time, the plane is 300 meters above the water, 430 meters from the observer. Determine the angle of elevation of the plane measured from the observer to the nearest degree. Well, I can't do anything without seeing some kind of picture or diagram, so I'm going to draw myself a little picture. There's my airplane. Here's my ground or water. I'm assuming he's sitting at a dock. It's a float plane, unless of course the question specified that. So here's Buddy over here. Whoops, it's a bad stick man. Sitting on his dock. Okay. Looking at a plane. He's looking at a plane that they say is 430 meters away from him. At a certain point where this plane was, I think it said 300 meters above the ground. We can assume that this forms a right triangle. We're looking for the angle of inclination to the plane. How's that for a nice fancy picture? So there's our picture. Next step is we need to label it. 430 is our hypotenuse. It's opposite to the right angle triangle. It's the longest side in this triangle, my hypotenuse. If I'm looking at this angle, this is my opposite side. This would be my adjacent side. Then I think, well, if I have this right triangle and I'm looking for this angle of inclination and I'm given the hypotenuse and the opposite side, well, which trig function relates opposite and hypotenuse? Sine. So I know that my formula is going to be sine of some angle is equal to opposite over hypotenuse. Sine of some angle, in this case, let's call this angle x. That's where the guy's sitting here, right here on the ground, is equal to my opposite side, which is 300, over my hypotenuse, which is 430. Sine of x is equal to whatever 300 divided by 430 is, 0.697644186. Funky decimal number, looking for an angle. Things are clicking and triggering in my head. Say, well, if I'm looking for a funky angle, if I'm looking for an angle and I have some crazy decimal number, then I have to do the inverse function of, in this case, sine, to get my angle. Now I can write down the 0.697644186. Your calculator does have the ability to carry those numbers to the next calculation, so you might want to play with that and figure that out. I also know that that number came from 300 divided by 430. So again, on my calculator, if I make sure that that's in brackets when I'm doing the inverse function of sine, I'll still get the correct answer. Either way gets me to second function sine 44.24071879, or in this case, it doesn't specify, to the nearest degree, 44 degrees. And there's example 3. Practice questions at the bottom here for section 2.4. I'm going to do my best to get the rest of the chapter 2 videos up sometime tonight so that you have them. But there's section 2.4 for you, ready to go for those of you that are keen. And don't forget, these questions are listed here because the only way to get better and proficient and faster at doing these calculations is to practice, practice, practice.